In this lecture, we are going to implement the program that we wrote in the assembly. This program in a higher level language like Python. Again, we will talk about programming language from the start and beginning in the next module, and we use C for that purpose. In here, I just want to do it in Python because it is faster, and also I want to create more of a simulation example so that you could see a mapping from instructions in assembly to Python or C. I just want to as I said, create just an example. So in here, if you look in the assembly program that we wrote, it's like we created two variables when we moved numbers of 5 and 2 into two registers. It's like just we created two variables. So in here in the Python interpreter, I say a equal to 5 to create a variable and hit enter. If I now say a or print a, you could see the value of a. Then I want to say b as another variable. You could change the name, anything that you want. Well, in the assembly, you should specify the register, and we have only a couple of registers. But in here in the Python, we just use a variable as a placeholder, as the registers are also placeholders. But in here, any name that you want. So b is equal to 2, and I hit enter. Next, we have the next command, which is comparing of the two variables that we created, and we said compare is equivalent to subtraction. So in here, I want to use the subtraction, and since if you look in the assembly, none of the operands in here, neither R10 nor R9 has been changed. So in here, I want to use another variable so that a and b are not changed. In here, I say a is equal to c is equal to a minus b and hit enter. Now if you want to see the c variable, we could just hit enter and see that this variable is equal to 3. Usually that when people write programs, they always actually choose meaningful names, but in here, as I said again and again, I want you to notice to the contents, because this is a educational program or lecture. So after that, you want to see, if you look jump in here, what it does is that we said it looks at the eFlags register and one of the registers in the eFlags, right? Specifically the parity flag or the P flag. And also, so what we are going to do, since this has changed that, and the parity flag actually itself changes based on the number of ones in the result of the last operation. So what we are going to do is to create another variable called d, and in this variable I want to calculate the binary equivalent of the number saved in C. If I hit enter and print the d, you see that it is equal to 0b11, which means because it doesn't show all the zeros before 11, that's why you see 0b11. Actually, we don't want to strip 0b from here. I just want to use another. All of these things are built-in functions in Python, which have been created these functionalities have been created, some of them, most of them by other developers, and some are built-in modules or functions, but all of them would be translated to the machine code at last so that the computer could understand them. The next one is type, and also the benefit of us using the Python is that it is interpreted. You could see them line by line in here, see the result line by line. So in here I say type d and hit enter. The type of the d, which is the binary representation of the number c or 3 in here, is a string. Now we want to count the number of ones in this string and make sure if that's even, because if that the number of ones in the string is even, then the parity flag would be set. So in here we use another built-in function called count. What we could do is to say d.count in here and 1, and it would just count all the ones in the d string. Now maybe we save it in another variable called e and hit enter. Now if we see e, it tells us that it has 2 ones in itself. Now what we could do is to say while true, or actually no, I want to say while e divided by 2 is equal to 0, which means actually a reminder. I'm gonna say that if e divided by 2 is equal to 0, which means that it is an even number, then I would want to, so actually let me see the problem in here. Yeah, I use 3 equals, and then I would want to just print the hello world in here and hit enter. And one more time. Now if you look, we have a loop printing the hello world over and over again. Now if you have a look again, well, you don't need to say to just know all of these commands in here. As I said, this is just an example. So if you look again, we created 2 variables, a and b, even though we could just actually I want to do it so faster in here. If I say a equal to 5 and b is equal to 2, I just want to show you different ways is equal to do. Then what we are going to do is to say a minus b, this value would be 3, right? We want the binary of this, the binary representation of this. After the binary representation, we want to count all the 1 values in here. And also at last what we are going to do is to say, just let me actually hit enter. Now say while this value in here, divided by 2, the remainder of the division of this value is equal to 0, then I would want to just print hello world on the screen. And if you hit enter, we have the hello world in here. So I just wanted to show you some different ways of implementing such a program. If you look in the Python, we were able to just implement it using just 2 different, or just 2 different 2 lines of code in here. But the main purpose of this lecture was that you somehow see the equivalent instruction in Python and also in the assembly. I hope it's useful.